Hello. So I'm going to try to explain how to do more complicated transformations of basic functions. So you have your basic function. A lot of times this is called the parent function. So in the case for a more introductory class, it's going to be something just like an absolute value function or the quadratic y equals x squared. So it's going to be a function that is pretty basic, and then you're going to learn to transform it. So this video isn't necessarily for someone who's just trying to learn the basics, although I am going to go over the basics. This is more about how do you do a problem that has 5 or 6 transformations in it. How do you make sure you do those transformations in the right order and that you don't accidentally mess things up? So that's what I'm going to try to cover. So the first things first is that our function is going to be y equals f of x, and we're just going to go over some basic definitions. So there are some transformations that you can do outside of the function, and then some that you can do inside the function. First, the ones that can be done outside of the function. So assume that c is some positive number, maybe 2 or 3 or 7 or whatever you want it to be. If you see your basic function, like absolute value of x, and a number is being added to it, like plus 2, that is just taking the original function and shifting up by that many units. So plus shifting it up 2. If you see the original parent function with a minus 2 after it, that means shifting it down 2. If you have the original parent function being multiplied by a number, then it's either going to be a vertical stretch or a shrink depending on if that number is greater than 1 or less than 1. So if it's greater than 1, 2, 3, 7, 19, then it's going to stretch. So what used to be a height of 2 now becomes a height of 6, for example, if your stretch factor was 3. For a shrinking factor, it's just going to be, for example, if your c is 1/3, then maybe instead of original height of 5, it becomes 5 over 3. You just multiply by a third. The last thing that you can do is you can reflect over the x-axis, and that would just be multiplying the parent function by a negative on the outside. Okay. And again, I'm not going to be going over how to specifically do all these. I'm assuming you at least know how to do the basic ones. You're just needing some help with ones that have multiple things going on. The other thing that you can do are inside of the function. So you have your parent function, f of x, whatever it happens to be, and you want to do something inside. The way that is best to think about this is not to think of it as necessarily doing something to the x on the inside, but rather you are replacing the x with something. Later as I'm doing the example, hopefully that will become clear. So in the first one, you replace the x with x plus c, like x plus 2. That will shift 2 units to the left. All of the inside the function transformations are kind of counterintuitive. You'd expect the plus c to go to the right. Well, it actually goes the opposite, it goes to the left. If you replace the x with x minus c, like x minus 7, for example, that would be 7 units to the right. So again, counterintuitive. If you're going to replace the x with some number times x, then that is either going to be a horizontal stretch or shrink by a factor of 1 over c. So again, there's some counterintuitiveness there because you take the reciprocal of the number multiplied by the x. And if the number that's being multiplied by x is greater than 1, it's actually going to be a shrink. So for example, if it was f of 2x, that's actually shrinking by a factor of 1/2. And if it was a 1/3 times x, that's actually stretching by a factor of 3. And then, of course, the last one, f of negative x, is reflecting over the y-axis. So let's do a problem where we try to do a lot of transformations all at once. So if I can try to get this all on the one piece of paper. Okay. So this problem actually has, what is it, 4 different transformations. Our parent function is absolute value of x. And to the absolute value function, I've got some kind of multiplication on the inside and a multiplication on the outside with the 2. I've got some kind of addition on the inside with the plus 6 and some kind of subtraction on the outside with a minus 1. So really you have to make a plan. You have to start with what your basic function is and only do one transformation at a time until you end with this. And that will also tell you how your transformation will happen. So, for example, this is going to be a little hard to write without bumping the camera. So, my starting is y equals absolute value of x. I'm always going to start when I'm doing this with the inside first. So I have 2 things, multiplying by 3 and adding 6. Now remember, you want to think of it as replacing the x with the transformation. So replace x with 3 times x, or replace x with x plus 6. You want to do the reverse order of operations, and I'll explain why that is. So in other words, we want to do the 3 first. So our first transformation is going from replacing the x in the function to 3 times x. So I've got y equals absolute value of 3x. Okay. The next thing that you... Well, so I'm trying to do a video. The next thing that you want to do is, again, do our next transformation. Sorry, got a little lost there. So now to do this x plus 6, you don't necessarily... sorry, I'm not... Let's just continue. Technically, I wouldn't normally do this, but I'm going to continue because it's a good learning opportunity. Now, if I were to do the next transformation, you might think, oh, you're going to do a plus 6. But remember, you have to replace x with x plus 6. So it would actually be y equals absolute value 3 times x plus 6. And this is not the same thing as that. This is 3x plus 18, which doesn't help us. Okay? So there's 2 ways you could do this. You could decide, you know what? In order to get closer to what I want, I'm just going to change this to a 2, because then when I distribute, oh, look, that'll end up being 3x plus 6. So I can think of this as, oh, I'm replacing the x with an x plus 2 to get what I want it to be. Or you can do what I originally said that I was going to do and then accidentally did the wrong thing. You can do the reverse order of operations. In other words, don't do the multiplication first. Do the addition first. So in other words, kind of as a side thing to do here, your original would be y equals absolute value of x. Then your first transformation would be replacing the x with x plus 6. And then you would replace the x with 3 times x. So y equals absolute value of 3x plus 6. Okay? What this shows us here is that even though this does the same transformations, the order matters. Here, if I do the multiplying by 3 and then do the adding 6, I get a totally different function, not the function I want. I have to do it this way. I have to replace the x with x plus 6, and then I have to replace the x with 3x. All right, now let's keep going here. Let me move this camera a little bit so you can see the original problem. Now I've just got a few more transformations to do. I'm done with everything on the inside of the absolute value. Now I just need to do the multiplying by 2 and the subtracting 1. Now I'll do the order of operations in the usual way. So now, remember our transformation is going to be done to the function. So you take your base function, which is this right now, and you multiply by 2. Okay? So this becomes y equals 2 times absolute value 3x plus 6. And then we have one more, which is taking the function you're starting with, and now we are subtracting 1. So, sorry. So y equals, write down all the same stuff, and then put a minus 1. So even though this looks like we haven't really done anything, You know, all we did was slowly build from the original up to the one that we actually want to graph. This is nice because you can do the exact same thing to your original in order to graph it. So if your original is absolute value of x, that just looks like this. All you have to do is ask yourself what happened in each step. This said, oh, we moved 6 units to the left. So now for this one, the graph is 6 units to the left. So you go over 6 units and you've got your V shape. I'm going to be a little lazy with the actual graphing here. Now, going from here to here, I replace x with 3 times x. Remember, that is going to be a, what's the word? A horizontal shrink by a factor of 1/3. So in other words, it may be a little hard to graph here, but put it over here. Whatever the distance is away from the y-axis, like this one is 6 away, it's now going to be 1/3 of that. So 1/3 of 6 would be 2. So now we're just 2 away for our v. And you do this for all of the points, and it's going to end up shrinking it down so it looks a little bit skinnier. Okay. Now this can be hard to do, so it may be useful as you're doing this, not just to draw it, but maybe start with your basic points of -1, -2, 0, 1, and or -2, -1, 0, 1, and 2, along with the outputs, and then just do the transformation to all 6 of those points all the way through. Then when you go from here to here, all you're doing was stretching by a factor of 2. So that means whatever the height is for this picture, you're going to multiply by 2, and that's going to make it even more stretched out. So, and then shift down 1. So your final graph will look like this. Now I don't have the exact numbers on here, of course, but that is the basic idea of the order of the transformations. Now, mind you, this transformation going from here to here was a little difficult because for every single y value, so you're going to have to look at a couple different points to make sure that your graph is all correct. You're going to have to take the y value and multiply by 1/3 to get the new y value. I only did it for the vertex because 6 was relatively easy to multiply by 1/3 to get the 2, and it's an important point. If you did this slightly out of order, kind of like I was doing up here, sorry, for these, if I decided to do the multiply by 3x and then do this, but do it with the 2, then I could have done it this way, and it would actually be a little bit easier. So I'd start with my regular absolute value function. This would say, oh, I multiply by, it would stretch the horizontal distance away from the y-axis. I would shrink it down to 1/3 of what it was. Well, that's a little bit easier to do when you're right beside the y-axis, so you'd get this steeper graph. And then you would just shift it 2 to the left, and that would get you to that picture down there. So hopefully that helps. There's obviously this problem didn't have any of the reflections, but it's the same thing. Like if this were a -2, I could have multiplied by a 2, or you can multiply by -2 all at once. I personally would just multiply by -2 all at once. So that just means whatever the y value is, multiply by -2, and that gives you the new y value. I hope this helps. These can definitely be complicated, but hopefully seeing one example where you kind of go through step by step to transform the parent function into the more complicated one helps to do more complicated problems.